Aromatic hydrocarbons. The chemist discovered a class of compounds which are unusually stable, and a number of these compounds are with distinct odor. This is called as these compounds are called aromatic compounds. The term aromatic is derived from Greek word aroma means frag- fragrant smell or pleasant smell. Aromatic compounds are uh, these aromatic compounds are classified into two types. Mainly, one is benzenide compounds and non-benzenide compounds. Benzenide compounds, these are the compounds which contain at least one benzene ring, at least one benzene ring or one benzene nucleus. For example, benzene, naphthalene, anthracene, biphenyls. These are all are benzenide aromatic hydrocarbons. And second one, non-benzenide aromatic hydrocarbons. Compounds which do not contain benzene nucleus but resembles with benzene in chemical behavior. For example, azulene, pherol, furan, thiophene, those are all non-benzenide aromatic hydrocarbons. And the next one, what is aromaticity? Aromaticity. The fragment odor of benzene and its derivatives led them to being classed as aromatic compounds. These aromatic compounds were considered to be those unsaturated systems that undergo with substitution reactions in preference to addition reactions is a special chemical reactivity. Uh, in aromatic, we can how we can identify the aromaticity. One rule is proposed by Huckel, that is Haeckel's rule. Haeckel's rule. We are using Haeckel's rules to find out aromatic and anti-aromatic and not aromatic compounds. The aromatic compounds are unsaturated compounds, and conjugated, unsaturated and conjugated compounds and cyclic compounds, unsaturated, conjugated, cyclic compounds and planar compounds and undergo substitution reactions substitution reactions and obey Huckel's 4n plus 2 4n plus 2 pi electron rule. These are aromatic compounds. Aromatic compounds are unsaturated conjugated systems, and cyclic compounds, planar compounds, undergo substitution reactions, prefer to addition reactions, and obey Huckel's 4n plus 2 pi electrons. Again, the rule is states that planar monocyclic completely conjugated systems that possess 4n plus 2 pi electrons are aromatic compounds. Planar cyclic completely conjugated systems that possess 4n plus 2 pi electrons are aromatic. Aromatic compounds are generally extra stable compounds. Similarly, monocyclic compounds, planar compounds, conjugated systems with 4n pi electrons, with 4n pi electrons are anti-aromatic. Anti-aromatic compounds. Compounds other than aromatic and anti-aromatic are non-aromatic. Non-aromatic compounds. Three types of compounds are there. We can see here some examples are there. I can show you. Hmm. In this example, you can take first benzene. Benzene is a cyclic planar compound and having three alternative double bonds. Three alternative double bonds. That means in here benzene every carbon undergo sp2 hybridization. sp2 hybridization. According to Haeckel's rule, 4n plus 2 pi electrons. 4n plus 2 pi electrons rule. 6 pi electrons are aromatic. 6 pi electrons are aromatic. Here, if n is equal to 1, n is equal to 1, 4 into 1 plus 2, that is called 6 pi electrons. Means benzene is having 6 pi electrons, that's why it is a aromatic compound. Benzene is a planar compound, cyclic compound, conjugated double bonds are present, and it obeys Haeckel's 4n plus 2 pi electrons. This is a aromatic compound. You can take naphthalene. Here naphthalene, here 5 conjugated double bonds are present. Here also every carbon undergo sp2 hybridization. sp2 hybridization, and according it naphthalene also obeys 4n plus 2 pi electrons, because for example if n is equal to total 10 electrons containing aromatic 10 electrons in presence in naphthalene, it is also a aromatic compound and it obeys Haeckel's rule, that's why it is also a aromatic compound. You can take anthracene or phenanthrene. In this anthracene and phenanthrene, 14 pi electrons are present. 14 pi electrons also obeys Haeckel's rule. These two are also a aromatic compounds. And in this example, this anthracene and phenanthrene is also having conjugated double bonds, and every carbon is undergo sp2 hybridization. And here non-benzenide compound is that is cyclopropylium, cyclopentadienyl anion, cyclopentadienyl anion. You can observe this cyclopentadienyl anion, cyclopentadienyl anion. In cyclopentadienyl anion, here two double bonds are there and one lone pair of electrons are present. If n is equal to 1, n is equal to 1, here also 6 pi electrons are present. It is also obeys Haeckel's rule, and cyclopentadienyl anion is also a aromatic compound. Here 4 n is equal, according to Haeckel's rule, 4n plus 2 pi electrons are aromatic. For example, n is equal to 1, 4 into 1 plus 2, that is called 6 pi electrons are aromatic. 6 pi electrons are aromatic. In cyclopentadienyl, 4 pi electrons from two double bonds, one, two double bonds, and remaining two electrons from here the anion. In cyclopentadienyl anion, here one electron pair on carbon atom. These two electrons also participated in aromaticity. And the next one, cyclopentatrienyl cation. In cyclopentatrienyl cation, every carbon atom undergo sp2 hybridization, and this cyclopentatrienyl anion or tropylium cation. Cyclopentatrienyl cation or tropylium cation. This tropylium cation is also undergo 4n plus 2 pi electrons. If n is equal to 1, 6 pi electrons. Here also propylene cation is also having 6 pi electrons. This is also a aromatic compound. For example, I can take for example cyclopropenyl cation. Cyclopropenyl cation. Here cyclopropenyl cation is also a aromatic compound. In this example, n is equal to 0. For example, n is equal to 0 means 2 pi electrons. N is equal to 0 means 2 pi electrons. 2 pi electrons containing compounds also a aromatic compounds according to Haeckel's rule. In cyclopropenyl anion is also having 2 pi electrons. That's why it is also a aromatic compound. And thank you very much.